Generative AI and automated tool chains have collapsed the cost of content production to near zero. This means operational noise is scaling exponentially within the enterprise. Organizations are now forced to process an unmanageable volume of synthetic output. For decades, business leaders relied on heuristic, intuition-based management, using established credentialing filters and gut instinct to evaluate talent and direct workflows. Those traditional structures are fracturing under this new synthetic load. A human brain cannot accurately filter thousands of AI-generated responses using intuition alone. The market is now flooded with synthetic verbal capital. Individuals can project the appearance of competency by generating highly articulate text, which is often disconnected from their actual ability to execute. Relying on intuition in an environment flooded with synthetic verbal capital leads to systemic failure. The old models lack the processing power required to separate signal from noise. Survival in this environment requires a transition to disciplined, system-driven calibration. This shift is built on objective systems reality, the practice of treating organizational behavior as a hard engineering discipline. The blueprint for this transition is the Systemores Behavioral Wiki. It is a centralized repository of operational frameworks designed specifically for the AI-native era. The wiki maps out 9 distinct operational modules. Together, they provide the instruction set to re-architect an enterprise from the ground up. These frameworks rely on a deterministic semantic index, which replaces colloquial management buzzwords with high-fidelity primitives to ensure every system remains empirically grounded. The transition begins with Module 1, Behavioral Capital. This functions as the asset layer of the enterprise, predating financial performance. Look at this isometric ledger representing daily execution. Green channels show cognitive ease through programmable defaults, while red blockages illustrate cognitive tax. Behavioral capital is the accumulated quality of decisions, compounding long before financial numbers register a performance shift. Operating on that foundation requires making decisions at founder speed. That brings us to Module 3. The Bob framework is an operational filter for recurring friction. A build decision dictates internal capacity expansion to handle friction. A bypass decision executes environmental redesign to remove the friction trigger entirely. By combining a strong base of behavioral capital with the Bob framework, the enterprise replaces slow human deliberation with deterministic logic gates. With the structural foundation set, Modules 2 and 6 establish the human-machine interface layer. Many organizations treat prompting as the primary way to interact with AI, but ad hoc human prompting is insufficient for reliable operations. This is architecture over prompting. Instead of typing commands, structured context pipelines route data. These gates use the behavioral lexicon, a strict semantic dictionary, ensuring only high-fidelity primitives enter the pipeline, rejecting vague management jargon. Operating without these pipelines invites the algorithmic alibi, using the output of an AI model to abdicate human accountability for a decision. Reliable AI integration requires engineered context pipelines. Operators must design and manage the data environment, rather than just reacting to the model's output. Moving up the organizational stack, Modules 4 and 5 address vulnerabilities in human talent acquisition and leadership. AI-generated synthetic verbal capital acts as a Trojan horse. Candidates submit articulate text that bypasses traditional screening, masking a lack of underlying skill. Allowing these synthetic candidates into the system results in the erosion of frontline execution, failures defined in this framework as micro-heists. To stop this erosion, you must deploy a signal preservation layer. This functions as a psychometric firewall to verify competence and protect talent density. Once talent is secured, you must defend against false empathy debt and the coaching trap, advisory loops that drain executive agency. This visual shows the solution, the Zero Ambiguity Standard. Instead of engaging in endless, soft management loops that compound errors, a precise, real-time correction severs the cycle and restores velocity. Defending organizational velocity requires treating human talent evaluation with the same ruthless signal auditing that you apply to machine code. Finally, we move down to the level of the individual operator with Module 9, the biological hardware layer. In a deterministic system, executive burnout is not viewed through a psychological lens. It is measured in strict engineering terms as battery capacity depletion. High-velocity execution requires somatic resource management. Operators must monitor and regulate their physiological state to maintain peak decision-making capability. Look at this thermal simulation. A high-pressure operator's physical nervous system is a hardware chassis, requiring regular diagnostic checks to prevent overheating under load. When that system overheats, the operator executes vagal CPU cooling. Translating somatic practices into hardware primitives allows operators to systematically bring their nervous system back to baseline. Optimizing the software of an enterprise is useless if the physical biological hardware of its operators is allowed to melt down. When we zoom out, we see the synthesis of all 9 modules functioning as a single unit. As this isometric model illustrates, the fully constructed enterprise operates as a precise, closed-loop system of high-density behavioral alignment. Contrast this pristine architecture with the chaotic outside market. Venture-subsidized platform providers engineer environments specifically for dependency and extraction. Without a closed-loop system, you remain vulnerable to that extraction. This framework treats organizational behavior as the foundational architecture of the high-velocity enterprise, a set of definable inputs and outputs that can be mapped, measured, and managed. Every decision, from biological cooling to context piping, serves to maintain the integrity of that architecture. Leaders must re-architect the interface between human operators and machine intelligence. Failing to calibrate these systems results in an enterprise that can no longer distinguish its own strategic signal from the noise of the synthetic flood.